Hey, welcome back. So last week's video, we introduced Docker Swarm, and we covered kind of the basics on how to, create a cluster, initialize the swarm, and kind of deploy your applications. In this video, I want to deploy that Laravel demo application. We have a number of past videos where we've talked about scaling that application and building it up and deploying it to production. So let's take a look at how we would use Docker Swarm to deploy that Laravel application to production. Let's get at it. Okay, so let's carry on from where we're at here. In the last video, I had this introduction to Docker Swarm. It wasn't about the Laravel application. It was more of a generic introduction to Docker Swarm and how to get started initializing the swarm and kind of going through the steps and deploying it to Amazon EC2. In this video, I'm not going to recover all those details. So some of the details about deployment and things, I'm going to leave that to that video that's already kind of captured there. But we're just talking about kind of the differences. What changes do I have to do in order to get this Laravel application to deploy? The last time we ended up with this kind of architecture. We had one manager node and we had multiple worker nodes. We actually had 4 worker nodes and 1 manager node. And the manager node is also a worker. So containers are actually scheduled to run on the master node. I didn't show that here because I wanted to just kind of clarify a concept. But in reality, that manager node can host containers also. All right, so circling back to our Laravel demo application, we want to deploy this to AWS. Okay, so this is our Amazon architecture. We have a single VPC with 2 subnets. We have a public subnet and we have a private subnet. And if we just look at the components, the 2 major components that we're going to deploy in this video are we're going to deploy an application load balancer and we're going to deploy a Docker Swarm. And we're going to deploy an application load balancer in the public subnet. So this will have a public IP address. When requests come in, this application load balancer will handle that initial request. It'll balance that request between the different nodes that are in our Docker Swarm cluster. And the Docker Swarm cluster, we're going to put that in our private subnet. Because each of these EC2 instances is going to need access to our Elasticache and our RDS, that's another change that we're going to have to make to our application. So that's the direction that we're going to head. So let's go ahead and make these changes. Okay, so right now I'm in my Amazon AWS console homepage. Before we go and start to look at some of this stuff, I do want to reference the Docker Swarm documentation. So if we were to look into the documentation, it starts when you see swarm mode down here and you get this overview. And then the docs are pretty straightforward. So there's quite a bit of content here. So if you have a lot of questions on how to deploy a stack to swarm, the information is really in here. It covers everything from kind of this overview to quick concepts, and if you just scan through some of this stuff, you're going to start to get some of the language and the context that's around it. One of the things that we have to do right away, and we talked about this in the last video, is we have to open up certain ports, and if you have questions about which ports, those are in the Docker Swarm documentation. So I'm going to close this tab because we won't need it anymore, and I want to go back to my Amazon AWS console page. The first thing I want to do is I want to look at our VPC. We have a virtual private cloud, and we named this VPC Laravel _demo _VPC. We've been using this for quite a few videos here, and I just wanted to take a look at the resource map. And so when you look at this resource map, you can see that there's a public subnet and a private subnet in the US East 1A availability zone. And then there's a public subnet and a private subnet in the US East 1B. So in this video, what we're going to do is we're just going to cover the minimal architecture we need to kind of show how to get this thing functioning. We're not going to deploy across availability zones to make sure it's highly available. I'm not going to ensure that there's multiple Docker Swarm master nodes or manager nodes so that the Docker Swarm cluster is highly available. Those things are important, but for this video, I just want to focus in on kind of that minimal, what do we need to do to get this thing functioning? Spanning multiple availability zones or promoting a worker node to a manager node, those are things that we can cover later on. So if we take a look at the details here, then you can see that our public subnets have access to the internet gateway. So directly access to the internet gateway. We have a NAT already available to us, and that NAT allows our private subnets to get outbound access to the internet. And that's important if we want our EC2 instances to be able to run apt-get commands or anything like that, where we're going to download packages from the internet. So this is our starting point on our VPC. I'm not going to do any changes here to the VPC. There's videos already out there that kind of talk about that. Next thing, I want to look at our EC2 instances that we have running. Right now, we don't have any instances running. So our first step is we're going to build some EC2 instances. And we went through these details the last time. I'm going to go a little quicker on this one. I'm going to build 5 EC2 instances. We're going to name them all Laravel Demo Cluster for now. We're going to use the Amazon Linux AMI, and they're all going to be a T2 micro. For our login, we're going to use the Laravel demo key. Our security group, In our network, we're going to modify this so that we're using that VPC that we just talked about. We're going to deploy these to the private subnet number 1. So these are going to be in that private subnet. They're not going to have a public IP address. So one ramification of us putting these in our private subnet is obviously we're doing this for security. But for us, as we start to build these things out, in order for me to SSH into these, I'm going to have a jump box that's in our public subnet. So I can SSH into an EC2 instance that's in the public subnet, and then from there, I can SSH into something that's on the private subnet. For our security groups, what I'm going to do is I want to create a new security group real quick. I have all these existing security groups, and because I know the ports for Docker Swarm, and maybe I'm going to do this again, I'm going to create another Docker Swarm cluster. I just want to go ahead and create a security group that takes all the Docker Swarm ports and opens them up for us. So we're going to name this the Docker Swarm security group. This is going to open all ports necessary for Docker Swarm. And then these ports are used for communication between the nodes. We're just going to add this to our Laravel demo VPC. And the ports I need are this port, and we are going to make it available only from within our VPC. We're going to have, it's not that, it's this. And again, only from within our VPC. And this was a custom UDP port here. The next one is. And only within our VPC. So these are the 3 ports that we need to open for Docker Swarm to function. Because this is inter-node communication, there's nothing outbound to the internet or anything. These are going to be all within our network, and so I can use this CIDR, which is the same CIDR for our VPC, to secure those ports a little bit better. There's not going to be any outbound rules, and we're going to go ahead and create this security group. So now I have a new security group. If I close this tab and I go back on over, and I'm going to select existing security groups, maybe refresh it here just to pull in this. So here's my Docker Swarm security group. I want that one for sure. I also want to have this Laravel demo web app security group. And then there's one more that I want to add. I want to make sure I get this one right. There is an EC2 RDS2 security group here. All right, so these 3 security groups, this first one opens up all the ports that are required for Docker Swarm. This one opens up the ports that are required for access to our web application. So that'll be our HTTPS, our HTTP, and our SSH port. And then this one is going to open up the ports that are necessary to communicate to our RDS instance. So I think those are all the ones we need. And then we're going to come on down. I think everything else is fine, except for we always need this user data. This is a bit of bash script that's going to run, and it's going to install Docker on all these EC2 instances. Everything else is we're just going to keep it all the same, and we're going to go ahead and build 5 of these. We're going to launch these instances, and we're going to go back, and we can see the ones that are pending are here. And we'll just take a little bit of a break while those spin up. All right, so some time has passed. You can see I've got the nodes for the swarm all renamed. I renamed them master, worker 1, worker 2, worker 3, worker 4. Haven't set that up yet. We're going to set that up next. I also configured a jump box, and this jump box has a public IP address. So we can see the public IP address here. If you look at all of the other ones, these nodes, they're all the same, but they don't have any public IP address. They only have private IP addresses. So if I want to configure one of these swarm nodes, I'm going to have to SSH into the jump box first, and then from there we can SSH over into the swarm. I've already copied the IP addresses that I need. I have them here in this document that's up here, and I also have a terminal window open right now. I'm just in a directory that's on my desktop, but inside this directory I have this PEM file, and that's the same SSH key that I used to create all of these instances. So we're going to go ahead and SSH into our jump box using that key. I'm going to specify that I'm using the key there. This first, the jump box, and I put little notes over here. This jump box is an Ubuntu instance, so it's an Ubuntu AMI, and the user for this instance is Ubuntu. And we're going to copy this IP address. I am already in the jump box right now, and I'm logged in as that Ubuntu user. And then I have already set this jump box up for us to use. And what I mean by that, if I look in the .ssh directory for this Ubuntu user, you're going to see that Laravel demo.pem key. I use secure copy to put that over there in previous videos, and I'm just using it at this point. We're going to use this key, which is in this jump box, to log into our other nodes now. Let's use that key to log in as the EC2 user on our master, or what will become our master node or our manager node. All right, and just like the last time, we have to run a command here, and I just have to replace this where it says private IP address with this IP address, which is the master node IP address. And now it says that this particular node is now a manager node. It's also a worker node, but to register our other workers, we're going to copy this. I'm just going to paste it down here so that I have kind of that command. So right now I'm SSH'd over into the manager node. Let's go ahead and exit this one. And we are going to go over to our worker number 1. Almost the same command, just replace the IP address. First time in this one, yes. And then now I can run this command to add this node as a worker of our swarm. And this is taking a bit of time. 2377. Let me double check the ports on these. So I set up that security group pretty quick. 2377. Let's go back to our VPC here. This is the CIDR associated with this VPC. 10.1.0.0. Is that what I put over there? Oh, I should have kept another tab. Let me duplicate this. I wrote the wrong CIDR. So when I created this Docker Swarm security group, I thought I remembered what the CIDR was, but it's not. It's this. It's 10.1.0.0/16. So I'm going to have to update the security group. These are the rules. We're going to edit these inbound rules, and we're going to add this as the CIDR block, or that, I guess. So now they should all be updated to 10.1. We're going to save this. I don't know how fast that propagates, but let's go ahead back to our command line and rerun this. And it's saying that it's already part, but I'm not sure if it completed it. So we're just going to leave, and we're going to run it again. Okay. So at this point, I'm pretty confident that this node, this is node 1 or worker 1, is part of the swarm. So we're going to exit here, and we're going to repeat that a couple of more times for the other 2 workers. Run this command. And while we're kind of going through this, and that was successful, this is something that we probably would have infrastructure as a code to do. So, doing this by hand isn't horrible, but it's not necessarily the best practice. Okay, so that one's in there, and I have one more to go. Okay, so that's in there. So I go back into my master node now. Actually, I believe I can run this from any of the nodes, but I'm just going to log back into the master node. And let's list out the nodes. And so here you can now see that we have, make this bigger, we have the 5 nodes. So 1, 2, 3, 4, 5. This node is marked as the leader. So at this point, our Docker Swarm cluster has been initialized and set up, and we should be good to go with that. We've got our swarm configured. We need an application load balancer now in front of this swarm. It's not technically necessary, but one of the challenges that we'll have is, we have a SSL certificate, and we want to have that terminated at some point. And instead of terminating on all of the worker nodes, let's just have it terminated on the application load balancer. And that way, when people hit this thing from the outside, they're getting something that looks secure. from our EC2 panel, if we scroll down a little bit, we're going to see this section on load balancers. So we're going to select load balancers. We don't have a load balancer set up anymore, so we're going to create a load balancer. There's a couple of different options here, and we're going to create an application load balancer. We're going to select that one. If you want, you can expand and kind of see how that works a little bit. We're just going to keep it like this. We are going to keep up with our naming convention. This is going to be our ALB. This is going to be internet-facing IPv4. For our VPC, we're going to select the one that we have, and you need at least 2 availability zones selected, so we're going to have to select both of these. And for both of them, I'm going to set this to our public subnet. So both of these public subnets are now going to be part of the ALB. For our security group, I'm going to use this Laravel demo workers security group. That opens up the SSH port, port 80, and port 443. I may add another port here in just a little bit, but let's just go ahead and get this part working first. For our listeners and our routing, I'm going to select HTTPS. It's going to switch to port 443. For a target group, I don't have any target groups, so we're going to create a target group. It'll open up a new tab here for us. And there's a couple of different target group types. We're going to keep it with instances, and we'll name this like that. We're going to do port 443 here, IPv4. That's our VPC, HTTP1, health check. We're going to switch to HTTPS, attributes and tags. We're not going to add any additional tags. So all of the rest of the stuff we're just going to keep the same. It is asking, hey, do we have any existing EC2 instances that are going to be part of this target group? And we do. So we have these instances, which are our Swarm cluster, and we're going to include all of these as part of that existing target group. And what this target group is this tells the application load balancer when it gets a request that's coming inbound, it's going to route it to one of these targets. So any EC2 instance that's in that target group will be able to manage or handle that request. So we're going to include these. And so those are all running, and we're going to go ahead and create this target group. Once this target group has been created, right now it's unhealthy. There isn't really a health check. I don't have anything running that will reply to the / command. So right now these might all come up as unhealthy. But what I'm going to do is I'm going to go back to, I think I can close this. We'll go back to here. We're going to refresh. That target group should now show up, and we're going to select that target group. So for the next part, we are going to create an SSL certificate. We've done this in the past, and it's pretty easy to do. So we're going to go ahead and request a new ACM certificate. This is going to be a public certificate. We have this domain called nextler.com. And then I'm going to add also a wildcard just to handle both of those. We don't need that one. So those two. Validation, we're going to validate this through DNS. It's pretty simple and easy. We'll go through that in just a moment, and we're going to go ahead and request the certificate. So right now, this is the certificate. It's kind of loading these domains up. So here they both are. So there's success. This says pending validation. If I refresh this, it says it's issued, success. Normally, this doesn't go to issued right away. Because I actually had an old SSL certificate that was issued, I think it's using the same name and value pairs here. So normally what you would have to do is you have to create records in Route 53. So let's go ahead and take a look at Route 53. I'm just going to keep this tab open. I'm going to go back over to maybe here. We'll look at Route 53. I should have one hosted zone. And inside that one hosted zone, if we look at that, there, this is the name that I believe the certificate is looking for. And then it's looking for this signature AC20DC. I don't think it must have changed those, AC20DC. So it could be that these name values are generated based upon something that's deterministic, right? So if you do it over and over again, you're going to get the same values. Feels a little bit like maybe that's not the secure way to do it, but anyways, that is what it is. So this is already kind of issued, and that certificate is all set up. So now I should be able to refresh here maybe, and I should see the certificates. Interesting. So what this is showing me is, if I go back to my ACM, I think it's this one, and I list my certificates. You see how I've got 2 of them. They're both here. I really only need 1 of these. So there's this one that was issued back in July. That's the 92. And then there's this one that was just issued just today. So I don't need this one. I'm going to go ahead and just delete this one. Refresh. I still have 1 certificate. So if I go to the application load balancer and I refresh this, I should only see 1 Nextler certificate, and that's the one that we're going to use. We're not going to do any load balancer tags or application firewall or global accelerator. We are just going to create this load balancer. So we're going to give this a little bit of time. It's provisioning right now, and we'll come back when it's provisioned. So the next bit of work that we have to do is add back into our application. So this is my Laravel application. For this application, I'm using the Laravel starter kit that I have on GitHub. First of all, here's the GitHub repo that you can see for this starter kit, and then there's a number of different videos that introduce different features. The last feature that we talked about was I have this kind of kit facade, and you can call kit prod publish, and it'll publish your built image up to Amazon ECR. So the next step that what we want to do, we want to be able to use that image that we just published to that ECR and deploy that to our Docker Swarm. So there's a couple of things that we have to do to be able to build an image that will run in that Docker environment that's part of our Docker Swarm cluster. So first of all, let's update our laravel.env.prod. When we've been building this previously, we've had to have a separate database and a separate Redis cache. But now that we're going to be pushing this over into our cluster that's in our production environment, we can now start to leverage our RDS instance for our database. So I've updated the host names for the read and the write. I also updated the database and the username here for that particular instance. And then down here, we're going to be able to start to use our Elasticache Redis instance. And so those are the changes that we need for the .env. We're just simply pointing our application now to our production database server and our production Elasticache server, our Redis cache. And then our next changes come in our docker compose-prod file. So again, when we run the command like kit prod build, this is the docker compose file that's being used for that process. Couple of changes that we made here. First of all, we only have 1 service now, just our web app. Previously, we had a database service and we also had a Redis service. So those 2 other old services have now been removed. We no longer need them. We're going to build an image. We're going to use that image in production. Production environment already has a standalone instance of RDS, which is managed by Amazon. And then we have a standalone instance of Elasticache or Redis that's managed by Amazon also. So those other services have been deleted from this compose file. Another thing that's been removed from this compose file, there used to be a tag, and I'll show you one over here, called container name. And container name is great when we're running this locally and we're not trying to scale this thing to multiple instances or multiple replicas. But because we're going to deploy this to our Docker Swarm, we need to allow Docker Swarm to name these containers. So I've removed that container name tag. And then the other changes, we'll just go from the top down. So the next change here is on line number 9. And on line number 9, I've specified the platform. If you don't specify the platform, when you use Docker prod build, it's going to use your local platform. For me, I'm on a Mac, and it's building this for an ARM architecture. If I build it for an ARM architecture, it won't be able to be deployed in that Amazon cluster. Those are all AMD-based machines. So we're going to specify the platform as Linux/AMD64. And then down here, I've added another attribute called image. What that attribute does is it specifies the name that we're going to use for this image as we build it. And you can see that it's pulling some of these keys from the environment file. So if we look at environment prod over here, I added a new variable called registry deployed version, which is set to v1 right now. And this is the registry repo, and that's the URL. And so you can see that those 3 things combine into kind of an image name. And then when we build it, it's being tagged as that version. And then finally, if we look at the very bottom, there's this new deploy attribute that has a number of variables inside of it. And one of the variables is replicas. And right now it's set to 5. And I'm just going to set that to 1 for now, as I don't need 5 replicas right when we start up. I'm just kind of testing. I want to make sure that the 1 is working before we turn on multiples. And then update config is useful as you update kind of the description, as you change the number of replicas or you change the version you want to deploy. Docker Swarm will take 2 nodes at a time and make those 2 nodes match what you wanted. So if you wanted version 5, then it'll take 2 nodes and bump them to version 5. After a delay of about 10 seconds, it'll move on to 2 more nodes. And that way, you always have some instances that are up and running. This is rolling through all your kind of containers and updating them as it goes. And then there's a restart policy that if something fails, it should try to restart. So I'm going to come back to our Amazon console. I'm over in the Amazon Elastic container. So you can type in ECR. You can get the Amazon Elastic Container Registry. This is the repository that we're going to be talking about here. And right now you can see I've pushed up a number of different images. The last one I just did recently, I built it and we tagged it as 1.1. It's also tagged as the latest. So let's see that kind of build process and that tagging process and see how we push them up. This is covered in a different video, but because it doesn't take that much time, we're going to just go ahead and do it here. So what I want to do is over in my Docker file, I'm just going to make a little bit of a change here so that it kind of forces a build. So we're going to run echo testing. And that bit of change, when it comes back through, it's going to see that something has been modified and it's going to create a new layer. So I'm running kitprod build. It's going to go through. Most of those layers have been cached. This is at the very end, so everything above it's been cached. And we're getting down to, this layer 30 of 30, run echo testing. That was not cached. So that was the new layer added. Now I'm going to run kitprod push. And if I run push without any attributes at all, it'll push and it's going to tag this as the latest. And so what I want to do is I'm going to just go ahead and add a tag in here. This is going to be let's call it 2.0. Let's just see what that does. So tag is version 2.0. It says it's completed. Scroll back over. We're going to refresh this. And you can see 2.0. Now the latest tag did not come with it. So if I want to tag that also as the latest, I run that one more time without anything, and it'll automatically put the latest tag in there for you. No new layers, everything should already be there, and it should not show up as a different version. It's just going to move that tag up. So there, we've pushed images up to our ECR. These images now can be used for our deployment actions, which is what we're going to get to next. Okay, so we got our images up in our registry. All our instances are running still. I'm just going to refresh this to make sure. And our load balancer, let me refresh this, should have been provisioned. Okay, so now this is provisioned. This has a DNS name. I'm going to copy that DNS name. Let's go back over to Route 53. Go to our hosted zone, Nextler. And what I want to update here is these records here. So this value, I'm going to edit this record. I'm just going to pull this out, make this a little more clear here. So when you edit an A record, you have the option to make it an alias. So I'm going to select the application and classic balancer. There's other options here, but that's the one I want. I'm going to choose my region, and the region that I'm in is Virginia, I believe. And so now I can choose the application load balancer, which is there. Then I also can set the routing policy. I'm just going to keep it a simple routing, but if you wanted to change that, you could change that there. Evaluate your target health. We'll leave that on. Say yes. Okay, we're saving this. So now it should have updated the alias. The other thing I want to do is this domain right here has a C record, has a value. I need to edit that. And we're going to swap that with the new one. And so you see how the name has changed a little bit, and we're going to save that. It's got a TTL of 300 seconds, so it may take a bit of time to propagate, but we'll see. So right now, if I go to Laravel demo.nextler.com, I'm not expecting anything here, simply because I don't have anything serving up any content. The ALB it has that target groups, but there's nothing kind of serving up the content there. So we're just going to leave that for now. This may also be because that DNS host change that I just made hasn't propagated yet, but we'll come back to that in a moment. I'm coming back to my terminal window here, and this terminal window, I have it open. This is still running the master node. I can rerun this docker node command just to show I can see all the nodes. All right, so I'm going to clear this directory. Right now, if I print the current working directory, I'm in the home directory for our EC2 user. If I see what's in this home directory, there's nothing here. I'm going to go ahead and make a directory called stacks. And I'm going to switch into the stacks directory. And what I'm going to put in here is I'm going to put the definition for the stacks that we're going to deploy to Docker Swarm. And these are just YAML files. And in fact, they look quite a lot like the Docker Compose structure. And there is some slight differences. It looks like these are based upon version 3 of Docker Compose, and it sounds like the latest version of Docker Compose has kind of changed a little bit. But I'm going to drop some content in here. And what I'm going to drop in here first is a stack file for the visualizer. We covered this in the last video. It allows us to kind of visually see nodes and what's deployed on those nodes. So we're going to go ahead and get out of this. And by the way, let's just be cognizant of this application runs on this image, and it's got port 8080 on the image, and we're exposing it as port 80. And then I'm going to have a Laravel underscore demo YAML file. And I'm just going to copy and paste some content in here for that. So if we take a look at this, this is just a very slimmed down version of the Docker Compose file that we have here in our development environment. This is the prod Docker Compose file. So I removed some of the unnecessary attributes. As an example, build, I don't have to do any building of an image over in our Docker Swarm. These ports here are using variables, and over here I've just removed all those variables and I'm just exposing the ports. So we are going to go ahead and save this also. Okay, so now in our stacks directory we have two YAML files that define the stacks that we're going to try to deploy. The first thing is I'm going to go ahead and just deploy our Laravel demo. I already know that this viz.yaml file, I don't think that this is going to work because I don't have a port 80 exposed in my ALB. If you remember when I created the ALB, I only created one listener. It was on port 443. This has port 443 exposed, so we're not going to try to get the visualizer set up yet. We'll circle back to that, but let's go ahead and see if we can deploy the Laravel demo stack. Okay, in order for me to run that Laravel demo stack, I need to set permissions up between our ECR instance and this EC2 instance. So right now, if I go back to our EC2, so this is our EC2 repository. If I look at the push commands, I need to essentially run this. Now if I copy and paste this over, so if I paste it in and I run it, I'm going to get this error. Essentially, this box doesn't have any permissions to run this at all. And to fix this issue, I'm not going to run Oz configure locally. Instead, we're going to attach an IAM role to these EC2 instances. So let's look at that. I've already created this role. I created it in the past here. There's an EC2 access to ECR. And I added the permissions to it. It's going to allow these actions, which essentially allow it to kind of do queries against the ECR registry. So this is the role that I want to add. And what I'm going to do is I come back to all my instances that are running here. So when I look at my instances, I have this swarm master. I'm going to go under action, security, modify the IAM role. I'm going to find that one, EC2 access to ECR, and I'm going to update it. And I'm going to do the same thing for all the other nodes too. Okay, so I've added that role to all these instances, and I'm thinking that that should fix this issue. So now if I go back and I rerun that command, now that command successfully runs. So now that our EC2 instance has permission to interact with the ECR registry, we can deploy our stack. And it has an attribute here with registry auth, because that's what we just established. This is the stack name. We're just going to call it Laravel underscore demo, and we are going to tell it which Docker Compose file to use. So once again, Docker stack deploy. This allows us to use those credentials that we just set up. This is the stack name. This is the YAML file that defines the definition for the stack. So we're going to run this. And I misspelled this with registry. I think it has an R on the end. All right. So attempt number 2, run it again. Still doesn't like that. Odd. I'm going to just copy and paste what I had. I believe this worked in the past. There it goes. What was different with that? Docker stack deploy with register. Oh, I misspelled it. It has an ER. All right, so there's my spelling. After I deploy this stack, then what we can do is we can look at what the services are that are running. It looks like I have one Laravel demo service. Broaden that out a little bit. You can see this is the image that it ran, which is the latest version, and it's exposed in port 443. The other thing I want to do is I want to see Docker stack PS, and then we'll call, you have to specify which stack you want to look at. And we can see that that has one instance running. So with that said, let's go back to our application. We're going to refresh this now. This feels like it is a firewall issue. Not reachable. The security groups for your load balancer don't allow traffic on this listener port. That's probably an issue. So the security group we have here, Laravel demo workers. Probably just selected the wrong one. I selected this one. Probably should have selected this app thing. Anyway, let's go ahead and just fix this up a little bit. So we're going to edit the security groups. And instead of demo workers, it's this web app. That's the one I want. I'll save the changes here. Okay, so now that's the security group. Listeners and rules has access now. Over here, that should work. This is a privacy error because of that certificate, and I was trying to reach it through the domain name for the application load balancer, but I don't need that. I can just run this one. Okay. All right, so a little bit of troubleshooting there. Just to kind of circle back, what happened was when I created my load balancer initially, I selected the wrong security group. I was trying to select a security group that opened up 443 and port 80 and port SSH, but I didn't do that. I only opened up, I think, the SSH port. So after changing or modifying the security group that's attached to our load balancer, now 443 is open, and it's redirecting that to one of the machines in the target group, and you can now see that we're getting a response. So our Laravel demo.nextler domain is functioning, and again, the data you see here is totally made up, but there is a query to the database. So this tells me that the connection to the RDS instance is working. This over here is the host name, and it tells me kind of the IP address. This IP address might not be the private IP address of one of those EC2 instances. Those instances, if you remember, those are our workers and our manager. But this IP address, I believe, is going to be the IP address of the container that's deployed to one of those instances. Okay, so we got one instance running. What I want to do now is let's modify our stack. And we are going to, up here, deploy 5 instances. We're still running the latest version, but if we want, we can kind of come back. If we look at ECR, it has some other tags in there. Let's run a version 1.1. And again, how the stack works is we've described what we want. We want 5 instances of this version, and then Docker Swarm is going to take that description, it's going to inspect what's out there, and it's going to do what it has to do to make our production environment match what we've described. So we're going to exit out, we're going to save this, and I'm going to run that same command, that deployment command again with the correctly spelled attribute there. And it's already done here. If I do a PS now, we should see 5 instances running. So there's web.1, 2, 3, 4, and 5. We can see that this is running version 1.1, 1.1, 1.1. So there's 1, 2, 3, 4, 5 1.1s. You can see that this web.1, that instance was running the latest, but now that was shut down and now it's running 1.1. So it's automatically inspected what we needed, figured it out, scheduled some changes, and it kind of processed those changes and they're all done. Let's come back to our web application. We're going to refresh this now. And what we should see is some different host names and some different IP addresses. I'm not necessarily expecting that every refresh hits a new worker node. As I go through this, I am seeing some duplicates, but overall, I should have 5 of those instances running. All 5 of them should handle the request responses for this as I refresh. And just so we can keep track, let's go ahead and put up a notepad here. And I'm going to, oh, I made that that's too bad. I made that, I think that must be a link or something. So I just need this first thing. So there's another one. That's another one, it looks like. This is also another one. C8B80, that is one of the older ones we have. 3.7. So we got a .8, .9, .5, and .6. Let's see if we can get something else. .6, .5, .6, .9. See our stack again. This is their 1, 2, 3, 4, 5 are running. So I would think I would eventually get up to them. So I do see there's one on 87. This one's off, it's shut down. There's 253, 175, 34. So one on each of the nodes, including kind of the master or the manager node. This is the one. So we just hit this, okay. All right, so after a little bit of refreshing, not sure what was going on. So the requests really weren't hitting this last node for a little bit. It was cycling between the other 4. I'm not sure if there's a particular reason why, but it did eventually hit that node. So there's our 5 nodes. Every refresh, theoretically, it's cycling between them equally. We can definitely tell we're getting different nodes on every request. And then if you recall, because I'm using Elasticache for our session, I should be able to log into this. And my session should stay logged in now. So I'm logged in as Bob Cravens. As I refresh this, I go across the different cluster nodes. My session is sticking with me because my session is being cached in Elasticache, which is not part of the actual node itself. So even though now I'm logged in, you don't see the login sign anymore. I'm still hitting different nodes, which you can see by the IDs changing. And my session follows me to that node because it's not stored on the node itself. It's stored in Elasticache. Okay, so let's take a look at this other stack. We have this Viz stack right here, and I want to deploy that. And what that is, that's a visualizer that will show us, on all the different nodes that we have, which one's the master, which one's the workers, what containers are running. It's just a real visual tool for that. So that's what we're going to deploy. It comes from this image. It's on port 8080, and this is what we want to get running. So the first thing I'm going to do is I'm just going to go ahead and run this stack. So we're going to docker stack deploy, and it's just, I think it's just a -c. I'll have to name it, I guess, viz -c, and then give it the YAML file. So now it created that. If we look at the services they're running on our Docker Swarm, we now have this one visualizer service. It's replicated once. It's only one of them is running. It's exposing port 8080. Now over here, if I duplicate this tab and I look at port 8080, and I'm going to take off the HTTP, it should just spin for a while. Okay, and after some time, it just times out. There's nothing there. And we kind of expect that. We haven't opened up a pathway for port 8080 at all. Let's go and look at our load balancer, the details here, and we just going to refresh this to make sure we're looking at the latest stuff. So here's a listener. It's on port 443. That's the only one that we have. So we want to take this ALB, and we're going to add another listener. Nothing in here, just kind of more informational stuff, but this is HTTP. We're going to do port 8080. We're going to forward this, select a target group. So now we get down to this part where it says the target group. I can't use this same target group. The reason why is this target group, if we were to look at it, this is HTTPS. I need to create a new target group. It's going to be almost the same thing as we did before, instances based. This is going to be the viz ALB target group, HTTP port 8080. So remember when we created the other target group, that one was HTTPS port 443. Same VPC, health checks, we're going to leave the same. I'm going to click next. Now I'll be able to add in my workers. So all of these are existing EC2 instances that I want them to be considered as part of this target group on port 8080. Include those. And I'm going to go ahead and create this target group. So I should be able to close this tab and go back over here, refresh, and here's my viz ALB target group. So it's a port HTTPS, or HTTP I should say, port 8080. Everything else we're just going to keep the same. We're going to add this target group. At this point we still have one more thing we have to fix, and it's indicated here. This port 8080, just like before, port 443, we had that issue with the security group we fixed. We need to fix this. So we're going to go ahead, look at our security group, which is over here. And there's no port 8080. So we're going to edit the inbound rules. This is custom TCP, port 8080. And this is going to be from, I guess, anywhere, IPv4 anywhere. Save that rule. Now if we go back to our load balancer, I can open up a new tab. So we go back here, we can refresh this. So now that port is open. So this listener should be able to serve it up. So now what's going to happen is, as a request comes in on port 8080, it's going to forward it to one of the EC2 machines in this target group. It doesn't matter which one it is, because at that point Docker Swarm will hand that request off to a container that can service that port. And even if that container is not running on that EC2 instance, Docker Swarm will manage that proxying of that request to the correct container. So now if I come back over here and I refresh this, if everything's working, we should now see our visualizer. And our visualizer currently shows the 5 demo apps, the Laravel demo apps, and then the visualizer here is running on the manager node, which is exactly how we thought it was going to run. Okay, so now that the visualizer is up and running, let's go ahead and do a couple of nice things here. So what we're going to do is we're going to modify our Laravel demo YAML. And what we're going to do is we're going to keep it version 1.1, but I'm going to deploy, let's say, 8 of these things. And we're just going to rerun our deployment for that Laravel demo stack. So it includes this little attribute. Rerun it, and down here we're going to see a couple of new ones pop on. So we now have 8 total. Here's 1, 2, 3, 4, 5, 6, 7, 8. They come up pretty fast. And if I go to my endpoint now, and if I carefully kind of watch these, I should end up with 8 different addresses. So now I'm using Docker Swarm. I scaled up this thing to 8 of them. Next thing I want to do is I want to do a rolling deployment. So I'm at version 1.1. If I come back to my ECR, let's go over to ECR. And I have 1.1. Here's a 2.0. So let's go ahead and, we're going to deploy 2.0 to our production. So that's pretty easy to do with the stack. Again, I just edit the stack, and I'm going to come in here, set it to 2.0. And then finally, I'm going to deploy that stack. And once I deploy that stack and we look at the visualizer, you're going to see it changing the versions of some of these things. So here's 1.1, 1.1. This is 1.1, 1.1. These are all 1.1s right now. Refresh this a little bit. All right, so it just put up, here's a 2.0 and here's a 2.0. So it deployed these 2 new ones. Let's make that even bigger. There we go. So 2.0, 2.0. There's 1, 2, 3, 4, 5, 6 of them running right now. I want 8. It wants 8 total. So it's trying to deploy a couple of new ones. They just popped on. Here is a 2.0 and here's a 2.0. So I got 2 2.0s, and it's rolling through all these old versions. They're going to pull off the board. They'll drop off the board. 2 of them just dropped off the board from here, and it's going to install one of the new versions. While it's doing all of that, I still have access to the application. The application is up and running. My ALB is managing to send the request to our target group, and our target group inside the target group, and Docker Swarm knows which containers can handle that kind of port, and it forwards it over to the running ports. So everything is functioning as it kind of rolls out this update. So at this point, I'm seeing 2.0s everywhere. And so we've officially deployed 2.0 to our production environment. Okay, so we very quickly got our project in this state. So just to kind of summarize some of the stuff that we did is, if we start from the outside in, request comes into Route 53. We configured Route 53 through the DNS entries so that all those requests to our domain, they get routed to this application load balancer. That application load balancer, we set up 2 listeners. One was on port 443 and the other's on port 8080. The 8080 was the visualizer, the 443 was our application, and those requests got forwarded over to their respective target groups. The target groups were the same instances. The EC2 instances were both the same in the target groups that formed like a Docker Swarm cluster. Using the Docker Swarm cluster, we were able to deploy the visualizer stack. We were also able to deploy our Laravel demo stack. Both of these, because of the permissions that we set up, could access the RDS and also the Elastic Cache. So we covered a lot in this video. So it's still a few things that we probably should discuss if this was a production environment. First of all, we have this architecture. There's one manager node for our Docker Swarm, and that's a single point of failure. So if I want to make this highly available, and I believe that 3 is the minimum number of manager instances where you could tolerate the failure of one of them. So I think architecturally you want to get to that level at least, where you have 3 manager nodes, and they can, again, they're also worker nodes, but you would have a level of redundancy then. Another discussion that's worth happening is, we have deployed these EC2 instances on our own. Those are ours to manage. So if there's updates that have to happen because of security or for whatever reason, we have to be able to drain off all of the containers that are on that node, do those updates, and then reactivate that node. It's not terribly hard to do. It's just something that we don't necessarily have to do if we were to use a service like Amazon ECS, which kind of takes care of all of that for you, manages those nodes. And especially if you start to use ECS with Fargate. Another layer that you can add to an ALB is we can start to add an auto-scaling group. And that auto-scaling group then can watch over our Docker Swarm cluster or our target groups. And so it can watch over those target groups, It can make sure that those instances are running, that they're healthy, and it's also monitoring, our CPU usage and all of that information so that it can automatically scale out or scale in the number of EC2 instances that are in our target group. That's an easy add, so we can add that to our ALB. And so one of the things that we'd have to figure out is when our auto scaling group was going to provision another EC2 instance, it would have to add it to our Docker Swarm cluster. That was, if you remember, that was a single line of code that we ran manually for all of those clusters. But what we should be able to do is add that single line as another command line in our user data bash file. So when our EC2 instance gets provisioned, that's automatically being run. So we would have to put some thought into how those are going to auto register. But again, that's a complication that we don't necessarily have to do if we're using something like ECS or EKS. It doesn't have all the features that something like, another discussion that's worthwhile is the discussion of which orchestration tool we want to use. Is Docker Swarm the one that we should be using? One of the pros that Docker Swarm has is, it's easy to install. It's already there. If you install Docker, you already have Docker Swarm. Not so much so with Kubernetes. With that said, Kubernetes has a lot of powerful features. And so we're going to take a look at some of those in upcoming videos. But for now, it's a discussion worth having, right? Is Docker Swarm the right fit? All right, so that's it for today. If you enjoy content like this, hit the like button and subscribe. I try to publish a video once a week, so hopefully I'll see you next week.